All right, we're going to get right into the next session. This is Peter Ferrie doing porting games from booter to ProDOS. Thanks, Peter.
So, I like to think of it as being as easy as 1, 2, 3. It's you save the data, you package it up again, and then we just return it on demand. If only it were that simple. To save the data, it often requires that we play through the entire game, and not all the paths are obvious. Fortunately, with emulators now, we have a much easier time of it. We can save the state in case we die by accident or because we're not very good at the game. But in some cases, it's necessary to die on purpose. For example, in Conan, when you die, you get a little small picture death scene. In some cases, it has clues as to how to solve some of the other levels in the game. And there are 6 different pictures that it can display. So if you don't have them all, and packaged up everything except those, then the game would crash when it can't find the picture it's after. But with the emulator, we can also trap the disk access. We can intercept the soft switches on demand. We can disassemble the code around where we're after. And we can change values on the fly for certain code paths to be taken in order to go where we need to go. In order to package up the data, we have the question of, do we save to multiple files or just one? If we use multiple files, it means less code in memory because we just have a simple lookup table. But it requires more data on disk. There's file system overhead per file, and we might end up filling a disk more quickly than we would have with just one file. And on the other hand, using one file means that we can use a map of the locations within our archive to find the location of the data we need, and at that point we need to consider things like data alignment. We don't want necessarily to span a block to access just one sector, because that would mean that we'd need to load into a private buffer and index into that to copy just the bytes we need, which might slow things down a little bit. To restore the data from multiple files, this is the code. That's all it is. And these are the data for it. So we can just replace the entire RWTS, or RTS, assuming it's read-only, with this sequence. And we use the trick here that the file length, if we make a very large length, ProDOS knows when to stop reading. So as long as it's at least the size of the file, it will stop for us. We don't have to worry about an exact number. In the case of restoring from one file, this is the code and these are the data. What I'm not showing here is the code that works out what the file offset is within the archive, and the code that sets the exact file size you need in order to read it back in, because that is very much dependent on the data structure you use, the techniques you use to find how to do that. We might have an issue if the game uses the BF page. One thing we can do is to find another page that isn't used, and then just use this code to swap it in and out. So you call this prior to calling ProDOS to swap the page back in, call it ProDOS, and then switch this back out and allow the game to continue running. If the screen holes are used, which is a problem I had with Earhart for the longest time, it worked perfectly on my hardware because everything always does. But some other people reported that in certain configurations it would crash, and it turned out that the screen holes were being used by Earhart to store actual code, and so I had to deal with that. The hardware was saving state about the current track and sector, so that when I messed it up, it didn't know where it was. It got confused. But we can deal with this by using this code, we simply set the slot number at this point here, and the first time we call it, change the store to a load. It will save the existing values that are in the slots, in the screen holes, to a private buffer. It's only 16 bytes. Thereafter, we change the load to a store and call this each time we want to swap it out in order to call ProDOS, and then swap it back in again afterwards. I was working on Crisis Mountain recently, porting that to ProDOS. Apparently it was originally developed as a DOS program. They simply removed track 11, so it has real track sector lists, and the game knows exactly where they are because they put the files on first, then erase track 11, and then they put the game code on with these hard-coded locations in there. So all I had to do was read the track sector lists to extract the files, make corresponding files in the ProDOS file system, and it only took me 2 hours. I was done. So this is great. I wish they were all like that, but they're not. And I got very, very lucky in the case of Crisis Mountain that all of the regions had unique track numbers. So, and there are only 6 files, 2 background files, 2 layouts for where the obstacles are, the waterfall, and the location of the rocks, and there's one file for page 3 locations, so it had all its vectors in there, and one file for saving the high scores. So I was able to just do a compare and a branch for each of the files, which simply set. In my case, I used one character to distinguish the different files, and so my branch just simply set the appropriate number, stored in the file name, and allowed me to load the file. Another problem we might have is if there are lots of data, and one solution is to compress them. We have a number of options, including APlib, LZ4, ZX7, for which I have decompressors in 6502 and 65C02. There's also a compressor called PU Crunch, which I found fairly recently. I'm still evaluating what I can do with that. It's compresses better than APlib, which is better than LZ4, which is better than ZX7. But it has some data tables that it needs to use for decompression, which means that it ends up being much larger as a decompressor than APlib, which APlib fits in less than 1 page of memory, so I can even put it on the stack and run from there if I have to. Obviously, compression requires more memory than it would have otherwise, because we have the packed data, the unpacked data, and the unpacker itself. One way we can minimize the increase in memory usage is to overlap the packed data and the unpacked data. But we can't unpack forwards beyond BFFF because there's no way to put the additional bytes that would need to be fetched in order to store to BFFF. So we can deal with that by unpacking backwards instead, starting at BFFF and going towards 800. We do this by taking the original input, we reverse the whole thing, then compress that block, and then reverse it again. So that then the last byte of compressed data would be the first byte of uncompressed data, and we go back to unpack the whole thing. The problem is when we get to 800, there's no safe way of loading bytes in prior to 800 that we can use to store the bytes to 800, because that's where the screen holes are, and ProDOS refuses to have a file load directly below 800. So we need to use a jump and restore technique. And it looks like this. If we have, for example, a block from 800 to 8000, we take the first 6 bytes. I chose 6 here because in the case of APlib, usually the minimum overlap I can support is 3 bytes. And so we have 3 bytes of overlap and then 3 bytes spare that we need. Place those at the end of the compressed block, So our new location is 806, our new ending location is 8006. And we have a gap in the front. We move the whole thing down to 803, and then at 800 we put a jump. That goes to the end of our compressed block where we have our unpacker. And then to unpack at 7FD, we just copy our 6 bytes back, and then we begin unpacking all the way down to 7FD after saving the values in the screen holes first. So once we've loaded the file in, we can afford to save that. ProDOS doesn't have to care anymore about what was there. As far as unpacking goes, I find it's best to display the title page as quickly as possible. So I pack that one separately from the rest of the data I want to unpack. Because once the drive turns off, there's no visible activity unless you explicitly code it in. So, and sometimes the unpacking can take longer than the disk read. In the case that the original read was, say, 4 and 4 encoding, which is very, very fast. I can't compete with that when I'm unpacking. So I need to have some kind of explicit activity. In the case of sneakers, when the original disk was loading, one of the creatures would stomp its feet once for every track that was loading, so you had this nice animation. For my file-based version, I simulated that by having the animation every 4K or so, because it has about 48K of data. It had this nice animation as well. In the case of Dino Eggs, the original Buddha would load the 2-bit array directly onto the screen, so you had this fluctuation while it's loading. It had the title screen, the credit screen, and then it had this garbage at the bottom. For my file-based version, I actually put the data that was being unpacked in there as well as the original location, so it had some variation as well. You can see it's doing stuff. And we place the packed data either before the graphics screen or after the graphics screen, depending on where it fits. So we can just unpack directly. Unpack and display the graphics screen first, and then unpack the rest. What if the image is too large to load if the graphics screens are avoided? Imagine we have a layout that looks like this, and this matches a number of titles, including Tomahawk, which actually loaded to the language card as well. It was solid. And we had the title screen right in the middle. The question is, can we fit this into one file? Because this is always the challenge I have first. If I can avoid multiple files, I find that's best, because then I can overwrite ProDOS if I have to, and I don't have to worry about disk access anymore. So the first thing is to compress it, and imagine it looks like this. To deal with this, we have to rearrange a little bit. So the first thing is we have our title screen in red. It can't load from there, so we have to move it out of the way. Move it down here. We take our section of code that was next to it, and we move it down, and we put the title screen in at 1 FFD. This is allowing for the 3 bytes of overlap that I would have with APlib. We take the rest of the data that follows where the title screen ends, and we move it up a little bit. And take the bit at the end that fits into that space, and we put it there. It's like a shell game. So now we have a rearranged image that fits in the same space as we had before, and that still fits into one file. But to unpack that, we load our original image. We take the bit that fits from the end of the title screen up to the end of the graphics screen, and we move that back to where it was at the end of the packed data. And then we unpack the title screen into the space that we just created using 2000. So now we have our title screen. We can display that. And we start unpacking from the end of our compressed region into BFFF backwards, go down to 4000. And then we use a trick that we make the unpacker aware that the compressed region spans the graphics screen. So we make a skip from 4000 to 2000 and resume unpacking the rest of the image all the way down to 7FD using the 3 bytes overlap that we replaced as before. So now we have one file that unpacks all 48K in one pass with the title screen in the middle. So that's read-only version done. In the case of something that wants to write to disk, saving high scores, for example, we take our original code that we use for reading and we make these changes. That's it. 1 byte. So we can deal with that by having 2 separate entry points, one that sets the read opcode, looks like that, the other one sets the write opcode, and then just use the rest of the same code. The only difference between the read and write beyond that is we have to set the exact length to write out. Otherwise, if we ask ProDOS to try and write 64K, it really will try, and then it tries to access the soft switch space to copy into its buffer, and the screen goes crazy. The system probably hangs. Hilarity ensues. Other issues we might have regarding compressed games in general is that what if 64K is used? Can we still have ProDOS in that case? We can if we move ProDOS to the auxiliary memory space. We can run from main and then have a little entry point that switches to Ox's memory and runs ProDOS and then switches back. But that requires 128K of RAM in order to run. Alternatively, we can copy the game into Ox memory with an entry point that switches back to main memory to access ProDOS. That also requires 128K of RAM. My philosophy, though, is that we shouldn't require more memory to run than the original used. So if the original game fitted in 48K, I'm going to fit my access in 48K, excluding the fact that ProDOS is in the 64K range. I do make an exception regarding the CPU, though, that I would generally require a 65C02 for unpacking just to maintain space. But I do have a 6502 version I've used in some cases. So I had some complaints that some people can't run things like Tetris on their machine because they only have a 6502. In any case, I try to keep it in the same space that I had before. And another issue we have with ProDOS is it requires 1 kilobyte of contiguous memory for its file-specific data. 512 bytes for file management, 512 bytes for its block that's the next block it wants to load in case you request it. So that's a bummer if you can't have a kilobyte available. And then we have the other problem of what if 127 kilobytes is used and then ProDOS is gone. And so I have a solution for that. I have a library that I call ProRWTS. It's a completely independent RWTS for the ProDOS file system. It does not rely on ProDOS at all once it starts running. And in fact, from a floppy boot that I have, it doesn't require ProDOS at all. It's able to, in just about 350 bytes, it's able to load in a driver specific to floppies that can then pass the ProDOS file system and find any system file that you nominate. It doesn't have to look for just the first one. Pick anything you like. The library has both floppy and hard disk support. It handles seedlings, saplings, and tree files, so you can go up to 32 meg files in a single file. It supports subdirectories, so you can open a subdirectory, fetch files from it. It can go as deeply as you like. It can read and write Ox memory directly, as long as you're running from either stack or language card. So it can switch over and just do the direct access. And the whole thing is less than 1 kilobyte of RAM in the default configuration of hard disk read only. It has 512 bytes of data for the single block at a time, and the entire code is less than 512 bytes long. Even within the read-only configuration, there are various options, the smallest of which is 132 bytes of code. That one does seedlings and sapling files, and it can read anywhere you like. As of today, I have all of these titles. Gumball was the first demonstration title I had for Pro IWTS, which I was all ready to release until 4 AM says it's too slow from floppy. Gumball's original loader is extremely fast. Pro IWTS, on the other hand, is faster than ProDOS, but nothing compared to what Gumball does. And so for that we came up with Gumboot, which is faster than Gumball's original loader. But still, I'm working on some things to make Pro IWTS faster from floppies. Plan to implement scatter read and in-place decoding so that I can compete with some of the other loaders. In the future, these other titles are coming. I was almost done with Up and Down, but I ran out of time because it uses all 64K of RAM and I'm having trouble fitting all my stuff in. But it's close. It seems to work. I have to go through and test the game. But I have one more title that I'm testing right now. It's my dream title for demonstrating Pro IWTS, and I hope it actually works. It uses more than 63K of RAM, so I was essentially required to use Pro IWTS support. It reads a great number of chunks from the disk, anything from 256 bytes up to 4.5 kilobytes at a time, and it was 384K of data. So I put the whole thing into one tree file and enabled tree support in Pro IWTS. I compressed the whole thing to reduce the amount of time it took to read, and now I'm faster than the original loader was. And it also writes to disk. Yeah, let me see if I can get to work. Prince of Persia running from ProDOS. And the difference in resolution, you see, this is the super high res version that you can see on the 2GS. So I managed to fit Pro IWTS in 2K, including the Unpacker. I used every single byte. I spent a long time optimizing it down to exactly 2K. At that point, I said, it's good enough, I'm going to stop. Made the demo, and then I did iterate after that to try and get a little smaller, see how small I could go. But then the different data structure I used to get the smaller space actually had an impact on the performance, and then it loaded noticeably slower. So I just left it as it is. I think exactly 2K is beautiful. Cause that's all the room I had. I needed the other 2K as a buffer for decompression. I compressed it down to 200K of data compared to the original 384. And it includes the super high-res picture at the end. It also has all of the Easter eggs. So I took the original 800K disk, extracted all the data from that, but that version did not have the Easter eggs. So then I had to go back to the 5 1/4 version and rip out the Easter eggs, pack it all together, and you can access the Easter eggs by, when you start up the game, type -prints, and while it's loading, hold down the key sequence for whichever the Easter eggs you're after, and it will show. It includes the motorcycle effect, the shift caret. It's only for hard-coded slot 6 though, because I couldn't fit the additional space I needed to work out which slot was running. And you can even save your game. In the release I will have later today, I have a save game with the end sequence ready to go. You can just copy the file over and load that and see what the ending looks like on the 2E and the 2GS. There's also the previously undocumented Easter egg that if you press the caret while loading a game or after you finish level 2, it will show an animation of Jordan waving. It's a double low-res image, and that one works as well. So you just ask it to load the game, and then it will play. So that's it. Thank you.
Time for questions?
Yeah, we got a couple.
Is the process of replacing the RWTS calls at all automated, or does it require walking through each game looking for the disk access?
It would require looking on a per game basis, knowing exactly where it is, and then putting in the appropriate code.
I just have a comment. If you're considering using ProRWTS, it's awesome. When we switched from ProDOS to ProRWTS for Lawless Legends, we got back 10K of RAM, and our zoom time pretty much halved. So it's an amazing little thing. And if you try to read the code, having great time is super hard to read.
Is this documented for RWS? Like, is there a place I can go and look at how you use it and stuff?
I should have said so. The bootloader is in GitHub already. Version 1 is also there, but version 2, which Lawless Legends is using, and Nox Arcade, I'm still iterating on some new options I plan to put in, but I will upload it as soon as I'm happy with it.
What compression did you use? What algorithm did you use? Did you write your own, or did you get one?
For Prince of Persia, I used APlib, which is a freely available compressor. It's not open source for the compressor, but my decompressor has a source available. It's on my GitHub page, along with my other unpackers. But I did originally try using ZX7 and LZ4, and it didn't do the job. I actually have a presentation about that on my website. I can show you afterwards. That at that time I was trying to get Prince of Persia floppy version onto 2 sides, which was never done before, in 16 sector format. And so I went through all the details about how the different compression techniques I tried. APlib was the winner in that case, and it managed to fit. So we have a 16 sector 2-side version of Prince of Persia as well. So, and in this case I had to refine the techniques I used for the compression to make it fit into my 2K buffer, because in the floppy version I had much more room to move. because I didn't have to deal with the file system. I could just load directly certain sectors from the disk and unpack those directly. But in the case of the file system, my buffer was much smaller, so I had to compress it even further. But that was just a matter of finding the right place to cut the data and then compress it. So, any questions? Okay.